Guys, welcome to this session on Python career paths by Intellipaat. In this session, we'll take a look at what are the career paths available to you as a Python developer. If you're a developer who has some understanding of Python, has gotten started with Python, learned the basics, but is now overwhelmed with the career choices that is available to you, and you wish to get started with learning about the new career choice and wish to explore all the career options and figure out which one is the best for you, then this is the live for you. We're going to cover different career paths. We're going to cover what are the technologies that you need to learn in order to get started with the career path. Obviously, there are a lot of technologies that come with a particular career option. So you need to learn all of them, but there are specific set of technologies which you can take a look at in order to understand which one serves you better in the long run. So we'll cover that, and we'll cover the salary aspect of each of the career paths. So we'll take a look at all of those. So let's get started. Before we begin, click on the subscribe button and click on the notification icon so that you never miss another update. Also click the like button and put down in the comments what technologies would you like us to cover next. So let's take a look at the agenda for the session. So we'll begin by taking a look at a overview of career paths. Of course, we can't cover everything that Python has to offer, but as career paths, there are certain career paths that are more lucrative than others, and we'll cover those in this session. So we'll firstly get an overview of those career paths that we're going to cover. Then we'll take a look at automation engineering. So this is one of the career paths that is really popular with Python. So how you can use your Python skills to automate certain things. We'll take a look at web development. Then we'll move on to ethical hacking. We'll then move on to game development, and then finally to the current and I think the most hyped up career option, which is the data science option. We'll take a look at all of those. After we're done with the presentation and exploring the different career opportunities, we'll then move on to show you about the resources through which you can learn these technologies. We'll guide you through portals, how you can learn these technologies on your own. So stick around for that. Also, in the meanwhile, during the presentation, if you have any questions, put them in the question box. Our team is there to help you out for any question that you might have regarding these technologies. Regarding anything that we are covering in this presentation, you can ask us a question and our team is there to help you out based on the questions that you asked. So let's get started. Firstly, let's take an overview of career paths that are available to us as Python developers. So Python is quite a versatile language. In case you've worked with Python for quite some time, you know that it is used in almost all fields. It is really easy to get started with, really easy to understand, really easy to use. So because of the ease of use and understanding, Python is quite popular in many of the circles that use programming. So because of that, it is used in many fields. Now you can have a few career options if you know Python. So some of those career options are automation engineer, web developer, ethical hacker, game developer, and data scientist. Now, these are not the only career options that you're limited to, but these are the career options that are most prevalent with Python developers. So if you know Python, it would be more worth your time if you try exploring these career options than other career options. So let's take a look at those one by one. And during the entire presentation, we'll focus on each one of these career options separately. We'll try to understand what this career opportunity involves, what does a person with a particular career path in these fields do, and how do they get paid, how much do they get paid, and what exactly does the entire technology stack look like for these job roles. So let's take a look at automation tester or automation engineer. Now, automation is done automation testing is done to write Python scripts that can be used to check that a computer software is behaving the way we expect it to. Although automation is not just related to computer softwares, but that's the major application of it, especially in the context of Python. So to give you an example, let's say that you are writing some code and you want to, before writing the code, you want to set up some infrastructure that's going to test drive your application and figure out whether or not it's working the way you wish it to. Let's say that you're trying to build a login screen, and what you want to do is you want some software that when you run it, it will open up your application, look at the input fields that are available, look at the labels that are available, figure out whether or not it says email and password, and whether or not when you fill a particular username and ID and click on the login button, does it show a particular error message or does it show a particular success message? All of these scenarios need to be covered in order for an application to be successful. Now, when you're building an application, one way you can do this is write some code, go back to run the code, go back to the application, and then do all of these tasks manually. Then if you figure out a problem, write the code again, then run it again, then all these tasks manually. You keep doing them again and again and again and again, and it becomes very repetitive and boring. When software can help you with that, then you should be writing software to do that. So that's why we're writing automation testing. So what are the tools that an automation tester uses? Well, automation testing involves use of many tools. Some of those are Selenium. So Selenium is, in case you are not familiar, it's a technology that's mostly prevalent in Java, but it has been ported over to Python as well. And what it does is that it allows you to write code that's going to just run a web browser and is going to interact with it like a user would. So it will take a look at a button, click on the button, scroll up and down in a list and look at particular elements. All of that is done using Selenium. Where Selenium is used is in automation testing and automation engineering. If you want to build a software that's going to verify that a particular user story is being fulfilled by your application, then automation testing is great for you. But to give you some perspective, if you have a particular application, such as the login form, but it's a web application, then you can use Selenium to open that application up. Make sure that it has particular labels. When it clicks on those labels, input fields are activated. Then you click, type in some username, type in some password, click on the login button, and you get a message that says you are successfully logged in on the screen. Now, if any of the steps in the scenario that I have described fail, then your tests should fail. And that's what Selenium does for us. It will make sure that all of those tests are passing or all of those steps uh, are being executed. And if they're not, then that means that we have run into an error and our code is not working the way we expect it to, and we have to backtrack. Then comes PyTest. PyTest is a testing framework. It allows us to write tests in Python. When you're talking about testing, you're talking about unit testing, integration testing, and acceptance testing. What we discussed with Selenium is called acceptance testing because it requires for your entire application to be running so that you can interact with it. On the other hand, integration test is just a few components of our application should be running so that we can check that they work well together. Very much like if you have a database module of your application that interacts with a database server, let's say a PostgreSQL server or a MySQL server, and you have your application and you want to make sure that your database module interacts well with the outside database, then what you can do is you can write tests that will call specific methods on your database module, and when they do, they expect certain return values. So to give you an example, let's say that I'm trying to create an employee management system. One of the requirements is that I want to store information about a new employee in a persistent stage. So I don't care how I get the information from, whether I get it from a web user interface, whether I get it from a mobile interface, or whether I get it from a REST API. What I want is to make sure that when I call a particular method with some data, that data is sent to the database server. It saves all that data and then it gives me back a response that acknowledges that the data was correctly saved. So that way you can be sure that your database module is integrating perfectly well with the outside world or an outside entity. In our case, that outside entity is the database server. And now that database server could be a local database server that you have on your own system, or it could be a database server that is hosted on a server farm. It could be a cloud database. There are limitless opportunities of variance there. But that's the basic idea. So that's integration testing. And then there's unit testing, which basically just means that you test the smallest individual unit of code. So for instance, if you are writing a library that is supposed to manipulate a string, so if I give you an account number, the string of in a string format, which is just a list of numbers or a string of numbers, I get 10 numbers and I want you to format it in an account format. So four numbers, then a dash, then three digits, then a dash, and then three more digits. If I want you to arrange it like those, then basically I can write a unit test in which I would call the function, pass in the string, and expect it to return with this a particular output that is formatted in the way I want it to be formatted. Now, that doesn't mean that that's the only way of doing it. Of course, you can write code like this without unit tests, but the reason why unit tests help is because they cover your entire application from the smallest individual unit. So even if you were to place this code in some other project, it's going to work the same. Now, PyTest is great for integration and unit test. The reason why integration and unit tests are done in PyTest and not in Selenium is because Selenium's job is to take a look at the entire application, while PyTest can be used for integration and unit testing. So then comes PyUnit. Now it is an alternative to PyTest, although it doesn't mean that you only have to use one over the other. There are many projects that use both. There are many projects that have modules that use both. So you need to understand which one suits your need the best. Also, it doesn't mean that since PyTest is good for integration testing, PyUnit is not. You can use PyUnit for integration testing as well, but it has really great features for unit testing and you should use it for that as well. These are the three technologies that you should get comfortable with if you are willing to learn automation testing. Once you learn these technologies, it can be really easy for you to pick up other technologies because they are quite similar to other technologies that you might need if you decide to become an automation testing engineer. Now let's take a look at the salary that an automation tester gets. So in the US, the salary is $98,000. In India, it's 6.1 lakh per annum, and in the UK, it's 62,000 pounds. Now, do note that these figures are average salaries. These are affected highly by your experience, the company that you're working for, the position that you're working in, and many other aspects such as the location where you're working at, what kind of job, what kind of tests do you write. There's a lot of variance there. So just understand which one would you want to use. Then comes web development. So let's take a look at an introduction of what a web developer does. So a web developer can use Python to build the backend of a web application, which can be used to serve either the entire web app or just the web API. Again, in case you find these words to be a bit jarring and little difficult to understand, you can ask questions in the question box. Our team is there to help you understand these things, or you can stick around till the end and we'll guide you through some of the resources through which you can learn these things. The choice is completely up to you, but yeah, we recommend that you ask as many questions as you can to clarify your doubts. Okay, so let's take a look at web development. Now, as mentioned here, we build the backend of a web application. In case you're completely new to the web and you don't understand how the applications work, basically in a web application, there's a front end and then there's a backend. So what the front end and back end do is that they allow us to separate these two aspects of the website. Front end means the part of the application that the user sees and interacts with. So it is basically the thing that you see on your web browser. When you're visiting a website, you look at a form, you look at buttons, you look at text, images, carousels, galleries. All of these things are built using front-end technologies. These technologies include things like JavaScript, HTML, CSS, and if you go a little deeper in those, then you have React.js, Angular, Vue.js, and many other technologies that make it easier to build applications at a larger scale. Now, if you go to backend, though, the part or that backend fulfills is the logic that needs to be happening on the server side. So when the user logs in, you want to perform particular steps ranging from validating the data that was sent to the web server, then extracting that data out of the request, sanitizing it if it needs to be sanitized, then saving it inside a persistent storage mechanism. It could be a database. Many People store it inside Excel sheets, files, however you wish to store it, depending on your use case scenario. Then you get the data, you store it, and if there is any error during the process, you send back the error. If there is no error and all the steps were completed successfully, then you send back a response saying everything happened as it should have happened. We have successfully processed your request. So that's the basically the part that backend deals with. It deals with data. All the visual style logic is done on the front end. All the data related stuff is done on the back end. So if you ever think about how the web server works, how does it store the data, that's because a developer has written the backend of the application, which listens for request, extracts data, processes the request, stores the data if necessary, returns back a response. That's basically our job. So as developers, we need to be able to figure out how to authenticate, how to authorize. That's all done in the backend. We need to figure out how to authenticate, authorize. We need to figure out user schemes, rules. We need to figure out a lot of different kinds of things such as persistence mechanisms and all of that. So that's how we use that. So, and there's also web APIs, which are just URL that we can hit in order to get some response back in a format that we can understand. Front-end applications that use JavaScript exclusively make great use of web APIs. What they do is basically instead of building the entire HTML page and then sending it over the wire, what we tend to do now is we send a lot of JavaScript that's going to take care of the building of the entire user interface, removing user interface elements from the screen, adding new user interface elements, and getting data from the internet. And the job of the server now is to make sure that the data is stored appropriately, and when the user requests for particular data, if the request has the appropriate authentication level and authorization level, then we can send back the response with the data. Else we send back a response with the error, and it's all sent in a format that's agreeable. In many cases it's JSON, but you could also send data back in XML, in YML. It's called YAML, YAML. Many other formats are available for you to use, but mostly JSON is used because it's easy to use and parse. So that's the difference between a web application and a web API. API only serves data. Application serves the front end by getting data from the back end and then putting it inside the front end and then sending it on the server. So after this, we can use Python to build the backend of the web application. That could be web API or web app, but we can use it to do that. Now, let's take a look at the tools that a web developer uses. So, web development involves the use of many tools. Some of those are, and the first one we are going to talk about is called Django. Now, if you have ever tried building an application or a web application in Python, Django is quite possibly the most popular web application framework in the backend. Now, why is that? Mainly because it's been around for a long time and it has a lot of features for you to use. The way Django is built is that it's built to be pluggable. So what instead of you creating one giant application that has all the features you need, what you do is you create a project that contains small applications. These small applications deal with different problems that need to be solved. Problems such as authorization, authentication, logging, validation. You can split these applications into small applications. By features, you can also break them up into smaller pieces based on the functionality that they offer. So instead of them being broken up into the feature that they provide, such as validation and authorization, we break them up based on the kind of features they provide to the user. So for instance, if you have an e-commerce website, then you have a website that is facing the seller. So a seller can update the information about their products that they are willing to sell through your website. And there's another site that's useful for buyers. They buy through the website. So both of these can be separate applications. This is why Django is so popular, because it's so pluggable and so easy to use in nature. It's also a framework that comes with a lot of utilities for you. So ranging from validation to building APIs, serialization, to creating forms, so using templates in order to build an application, serializing data so that it can be sent via a web API. There are a lot of things that Django allows us to do. So we can use that as well. Django was predominantly used in the news agencies, but then since then it has been released for public to be used. It's currently in its third version and it's very popular and getting more popular by the day. Then comes Flask. So Flask is a micro framework. It's not exactly like Django because Django is not a micro framework, and the difference between a micro framework and a framework that's not a micro framework is that a micro framework is a framework that deals with very specific set of constraints. So if you want to be a developer that uses micro frameworks, then you have to hand roll your own solutions. So to give you an example, Django has its own ORM. ORM stands for Object Relational Mapper. Basically, it makes it easy for us to deal with database objects. So if you want to access something from the database, get the data, and then push all the data that we get to a particular data structure, Django will do that all automatically for us. Flask, on the other hand, doesn't do that. What Flask does is that it tells us that how to get data from an HTTP request, how it can intercept data, how it can allow you to respond to particular URLs, but all the other tasks such as validation, database connections, and all of that, you can take care of it on your own, and Flask will not force a library upon you. The reason why Flask is so popular is because it allows you to mix and match components for yourself. So if you have written the code correctly, then you can theoretically remove one database module and replace it for other database module. So for instance, you're using SQLite as a database server, but quickly you realize that this is not going to scale because it's not meant for production. So if you want to change from SQLite to MySQL in a database for a web application that is of considerable size, then what you can do is write a new module, make sure that the integration tests that the automation tester has written is working, then replace the current module with the new module that works in MySQL, run integration tests, acceptance tests, whatever. If everything works, you can deploy it and it works fine. So there's a lot less friction because of that. And Flask allows you to do that. In Django, it already comes with an ORM. It already configured and you can add more features into it. But opting out of it and using a new ORM and integrating it with the current framework, it's going to be really, really tricky and difficult. And this is why many people don't like doing it that way. Flask also allows you to use libraries for other platforms, such as or other features such as validation, HTTP request parsing, and many other things. And since Python is so popular, there are so many libraries for performing these tasks. In fact, there are libraries that work well with Flask and integrate well with Flask automatically. So you can take a look at those as well. Then comes Web2Py. Now, Web2Py is also a web application development framework. It's quite small. It's not very popular, but it is quite useful when you're getting started. So if you don't understand much about the HTTP request cycle, you don't understand how does the entire HTTP request cycle work, how do you get the request, what exactly is inside a request, how do you parse it, get the data out of it, how do you work with the data and all of that, then Web2Py is a great starting point. It's not really high level, so you do get some understanding of how things work, but it's not so low level that it's really difficult for you to understand how things should work and what you can do to build these applications. So you can take a look at Web2Py. It's also a micro framework. It doesn't ship with ORMs and validation libraries, but that doesn't mean that it's less than Django or it's not as good as Django. You can choose to use your own libraries or you can write your own custom code to perform these tasks. Now, the reason why these three are mentioned here is because these are the most popular. Django is the most popular when you're trying to build an application all by yourself and you need a lot of code generation and tooling. Flask is also quite popular because it allows you to build small self-contained services that you can deploy on clusters. Web2Py is great for getting started, but it's not very popular as of now. And if you wish to use Web2Py, you can. Let's take a look at the average salary of a web developer that uses Python. So in the US, it's $104,000. In India, it's 7.25 lakhs per annum. And in the UK, it's 76,000 pounds. Again, these are average salaries, these are median salaries. You can think of them as being influenced by your career options, companies you're working for, experience, what you have done so far, what are the precedents set by the companies, how much do they pay. That also varies depending on what the work that the company does is. If it's a product-based company, you might get paid more, and if it's a service-based company, then you might get paid less, depending on the size of the company and its internal structure. Let's take a look at ethical hacking. Again, if you have been working with computers for any amount of time, hacking is a term that you must have come across. So, an ethical hacker, as the name suggests, is a person or someone with the profession of ethical hacking is a person who tries to break into a system in order to find out security loopholes that need to be fixed. Typically, these people are authorized by the system owner who owns the system in which the hacker tries to break into. So, what the ethical hackers do is they get hired by companies under specific contracts, and they are told what are the systems that they can interact with, how can they let the company know what are the vulnerabilities they can find, and how do they solve those vulnerabilities is going to be something that needs to be guided by the ethical hacker as well. So that's what ethical hacking is about. It's about using your skills in order to break the security of a particular system and then figuring out how you can solve those systems to make them more secure. Typically, people are paid for this. They're paid handsomely for this. For the sole reason that companies want their systems to be as secure as possible. So they even organize hackathons in which they give specific set of people some numbers to break into these systems, and once they do, they can just uh, perform a certain task that lets the company owners know that some people have broken into these systems, and they will be paid handsomely for that once they reveal how they do it. The term ethical hacker has the word ethical in it because the hackers are not allowed to snoop around in the system. That's illegal and they will be punished for that. So let's take a look at the tools that ethical hackers use. So ethical hacking involves use of many tools. Some of them, let's take a look at this. The first one is Scapy. This is a tool that is used to monitor the network flow. Once we try to perform ethical hacking on any system, we do need to figure out how does the network work and how the network packets are flowing in and out. What Scapy allows us to do is that it allows us to manipulate the packets that are being sent from our computers and are being received in our computers and in those computer networks. This was originally written in Python, but it's available in different packages as well. It can be used to forge and decode packets and then send them back onto the wire. So if I want to spoof a request, make some changes to the request that is being sent by my web browser, I can do it by using Scapy. It was written in Python. You can take a look at that and understand how it works. It can be also used for handling tasks like scanning, trace routing, probing, unit testing, attacking, and network discovery. These are all tasks that would make sense to you once you become a ethical hacker. In case it doesn't make sense now, it doesn't really matter because that's really what Scapy does. Then comes FlowGrep. If you've used Linux for any amount of time, you must have come across a utility that's called grep. If not, then you can open up your Linux terminal and type the word grep. It will show you that it is an application that is used to find patterns in strings. So if you have some text data and you want to find some sort of data that matches a particular pattern, then grep is the tool that you use. Grep is used with a specific set of technology called regular expressions. Regular expressions are a very powerful tool for us to show how a particular pattern looks like. And then that pattern is what is going to be used in order to, we take the pattern and then we pass it through grep with some text. That pattern is going to be matched with the entire text that we have, and it's going to show us all the occurrences where the text. Flow grep allows us to do the same thing but with the network flow. So if any data is coming in or going out, flow grep allows us to take a look at the data and check whether or not it matches a particular pattern. It's great for when you want to take a look at what kind of IP addresses are we getting. If you want to take a look at whether or not you are getting requests from IP addresses that range from a particular number to a particular number. If you want to blacklist some IP addresses, then you can check whether or not they're correctly blacklisted using flowgraph. And there's a lot more you can do. You can take a look at the authorization headers. You can take a look at spoofing mechanisms. There's a lot that you can do with that. Now let's take a look at subroot. In case you've not worked with subroot, it basically allows you to brute force and figure out all the subdomains of a particular website. If you've ever worked with any website, then you know that you want to firstly figure out the subdomains of a website. So for instance our website intellipaat.com, if we have subdomains of it such as blog.intellipaat.com, ide.intellipaat.com, mail.intellipaat.com, employee.intellipaat.com, these are the kinds of subdomains that you might find in a company like this. And the reason why these subdomains are important is because all of them are pointing to might be pointing to different servers, different applications, and if you get access to one of those, then you can use that access to exploit and get access to other users' data as well. So if an employee is logged into a subdomain that relates to the employee world, and they have the username and password stored in that system, and if you get access to those, then maybe the same username and password can be reused on other sites on which the employee might have some access to. So that's one way of doing it. Also, if you have a password available on a site and you can reverse engineer that password, then you can reverse engineer all the passwords that are available in the database server. So that's basically what a subroot packet does. Now you can use Cappy, you can use flowgraph, and you can use subroot, and there are many other applications and packages that are available for you to use. These are all written in Python, so you can take a look at those as well. Very easy to use. They come with several operating systems installed with several operating systems such as Kali Linux. So you can take a look at that as well. In case you are not familiar with this and want to learn more, stick with us till the end of the presentation and we'll guide you through some of the resources. Let's take a look at the average salary of an ethical hacker. So in the US, it's $110,000. In India, it's 9,25,000 rupees or 9.25 lakhs per annum. And in UK, it's 86,000 pounds. Again, as we have said in the previous sections where we have discussed the salary, that this is all something that can be attributed to the company, and this is basically an average salary. So it could be the company, the position, experience, and a lot of other things. Now let's take a look at game developer. Now a game developer uses Python to build games which can be played on a variety of platforms such as computers, mobiles, etc. These games can also be played on consoles such as PlayStations, Xbox, and other platforms as well, such as Nintendo and all. Now, these platforms are really important, and the game development community builds games for multiple platforms at the same time. So you can use Python to build games, you can use Python to add features, you can use Python to build, add particular functionality to a particular object in the game. So to give an example, the way game development works is that firstly they start with something called assets. Assets are basically just the characters and the environment that is used inside a game. If you've ever used to play a game like Mario or anything like that, the characters and the entire environment is called an asset. It is created using tools like Photoshop and 3ds Max and many other kinds of tools. Once those assets are created, they can be exported and then imported into game development engines, which will then allow you to figure out what you want to do. So you can write code to make sure that it moves when a user presses a particular button, that it jumps when a user plays a particular button, and when it jumps, a particular noise is given out. So all of these things are possible. This is where Python comes into play. It's the language, or it's one of the language that you can use to do so. Let's take a look at the tools that are available for you to use when you want to develop games. Now, game development involves use of many tools. Some of those are firstly Pygame. Pygame is an open source library that allows you to build games using Python. It's by far one of the most popular libraries that are available right now for game development. Although there are other libraries available as well, which we'll take a look at, but Pygame is by far one of the most popular ones. It is cross-platform, which means that if you have a code base that uses Pygame to build some game, then you can use the same code base to build a game that runs on Windows, that runs on Mac, that runs on other platforms as well. Now it includes a computer graphics and sound libraries as well. All of these are designed using Python. So you don't have to worry about how you're going to use it because all of this is going to be done using Python as well. And the sound and gaming engine libraries, they all take care of the graphics and the sound requirements that you have. Also, you can load your own sounds and graphics on the game as well, and then you can build the entire Python game using Pygame yourself. Currently the latest version is Pygame 2. It's been in development for a long time. There might be some backward compatibility issues, but it's mostly fine. So that's how you can start with Pygame. Then comes PyOpenGL or PyOpenGL. OpenGL is basically a technology that allows us to build 3D games, and PyOpenGL is something that allows us to write code in Python to work with 3D assets and work with those. Now, PyOpenGL is a large package that wraps mostly up to version 1.2 of the OpenGL API. However, it doesn't try to clean up the API and present a more Pythonic interface. So if you want to write code in Python and work with the OpenGL software available, then you can take a look at PyOpenGL platform. The reason why OpenGL is so popular is because it's very performant. It is one of the most standard ways of doing things. It has a really great graphics engine. It does ingest graphical assets quite quickly and runs really fast. So you can take a look at those. Now, OpenGL is a cross-language and cross-platform package. So you can take a look at other languages that implement it as well. Typically, developers use C#, JavaScript, C++, Python, and other languages to work with it. What it does is that it allows us to render 2D and 3D vector graphics. In case you're not familiar, there are two kinds of graphics, vectors and raster. Vector graphics are graphics that use technologies like SVG and all that make it very easy for us to create assets in which you can zoom into and they won't pixelate. On the other hand, in raster format, when you have some image, when you zoom into that image, it's going to be pixelated if it's zoomed enough for a really large extent. So you need to make sure that you understand how you're using that. So OpenGL is a cross-platform application programming interface, and the API is typically used to interface with the graphics processing unit. So OpenGL mostly works with GPUs. Then there's Kiwi. Now Kiwi is not that popular of a programming environment in which you can build Python applications or Python games. It is quite popular in some circumstances, but it's really, really useful for people who want to get started with it. You can use it to build mobile applications, you can use it to build desktop applications, and using that, you can build games that are really popular. In fact, there are many games that have been built using Kiwi. One of those is Chisholm. It's one of the most popular Python games that are available, and you can use it on multiple platforms. It's an open source framework, so you can take a look at the code on GitHub. If you want to add some features to the code, you can do that as well. And you can use it to build games for Android, iOS, Linux, Mac, Windows, whatever, because it's cross-platform. Now, let's take a look at the average salary of a game developer. The average salary of a game developer is $115,000 in the US, 8.5 lakhs per annum in India, and 72,000 pounds in the UK. Again, it's influenced heavily by the restrictions that are put on a particular employee's career. So you could get a better salary if you are more experienced, if you are working in a better company, and a lot of other things. Now let's take a look at data science. So a data scientist takes a lot of data, gets useful insight out of that data, and trains a model which can be used to make predictions or classify some data later on. So the major breakthrough in the field of artificial intelligence, machine learning, data science, and all of this it has been possible because of a lot of data and a lot of processing power being available to us. A lot of data is being created every day, and how we can use that data to our advantage or to the advantage of a particular corporation is what the aim of data science is. If we have a lot of data, can we gain a lot of good insights from that data, and how we can use that data later on to make predictions about the future? Can we extract some trends out of the data and all? Let's take a look at some of the tools and libraries that developers use. So data science involves a lot of many tools to be used. Some of those are firstly pandas. Now pandas is a data manipulation library. It allows you to load data from multiple sources such as CSV files, database tables, online internet files, and many other kinds of files. What pandas allow you to do is then after loading the file, you can manipulate it in multiple ways. You can group the data, validate it, segregate it, remove some elements, drop some elements, change some elements. If you have data that is missing in some columns, then you can drop those columns, you can fill the missing values. All of that can be done quite conveniently using pandas. It's quite popular for that reason alone, because it's very easy for you to use. Also, it allows you to write code that's very easy to read and understand. Then comes NumPy. As you already know, NumPy basically is used for numerical calculation, as the name suggests. So NumPy is used when you want to write code that is dealing with numerical calculations. It's very fast. It instead of using the internal Python representation of data types, it creates its own representations that sheds off a lot of weight. So all the unnecessary information that Python stores about a particular data type that is not necessary for mathematical operations is just removed when you're using NumPy, and that's what makes it really fast. NumPy is also very fast because it has been written specifically for numerical calculations. This is why it's especially used in data science and in machine learning, because there you need really fast calculations. Then comes scikit-learn. Scikit-learn is a package that has a lot of libraries in it. These libraries are used in order to build applications and models that use specific machine learning or data science algorithms. If you've ever come across algorithms such as linear regression, logistic regression, decision tree, random forest, and all of these are all implemented already in scikit-learn. So if you want to get started with data science and you don't know how to implement these algorithms, you don't have to worry about it. All you need is some data and Jupyter Notebook installed on your system with these packages. We recommend that you use Anaconda, but it's not necessarily the case that only Anaconda needs to be installed in order to use these technologies. You can install them all separately by yourself, although that is quite a task. Once you've installed these technologies, we recommend that you use open up Jupyter Notebook, import these packages, and use them to the best of your abilities. After importing the data, you can train the models and you can make predictions for the future. Depending on the size and quality of the data, the predictions can be really good. And also, scikit-learn offers you some packages and utilities, allows you to check the accuracy of a particular model. Now let's take a look at the average salary of a data scientist. In the US, it's $112,000. In India, it's 9.75 lakhs per annum. In the UK, it's 87,000 pounds. So you can take a look at the salary estimates. Again, these are influenced by the same features that we have taken a look at previously. With that, we've come to the end of the presentation. Thank you so much for joining us. In case you have any questions, you can contact us on the numbers that are listed on the screen. If you are more of an email person, you can contact us on the email that's listed on the screen. Our course advisors are there to talk to you 24/7. In case you are looking for some of the resources through which you can learn these things, let us now guide you through some of the resources which you can use to learn these technologies and get started in a career that involves one of these career paths that we have discussed.